Here we go. Are you gonna? My microphone. I can't tell if my microphone's working or not.
I think it is because the top, that little thing moves.
Yeah, I don't know.
I don't know. Oh yeah, the sound on some of the videos is really...
We're just gonna go for it. All right. So, give yourself a right triangle that looks something like this. Okay. And I've given you an angle over here, which we're gonna call theta. All right. So in a right triangle, we have 3 sides. Correct? What's the longest side called? There's a name for it. What's the name?
Hypotenuse.
Very good. Right. So this one is the hypotenuse. Okay. So if this is my angle on the lower left-hand side, which one represents the opposite side, and which one represents the adjacent side? Opposite is over here. Very good. And then that makes this one the adjacent side. So now we have 3 sides of our right triangle that which we can talk about. Right? Once we have all 3 of these sides, we can start talking about them. So we can talk about the sine of angle theta. We can talk about the cosine and the tangent. Of course, then we can also talk about the cotangent of angle theta. The the secant. What's that? You're not into it?
Cosecant.
Yeah. All right. All right. So, how many remember SOHCAHTOA?
Yes.
Who remembers that?
AC expansion.
Yeah. I could never remember SOHCAHTOA because I can never remember how to spell it. Okay. Well, I have something. I have a different one. But the sine is equal to the ratio of the opposite to the hypotenuse. Okay. The cosine is what? What's cosine? Very good. Adjacent over hypotenuse. And what's the tangent? The opposite over the adjacent, right? So, the SOHCAHTOA thing is the way you spell it. SOHCAHTOA. There's a couple of them out there, right? Then we automatically have the bottom 3 because they are reciprocals of each other. So the cotangent is defined to be what over what? Adjacent over opposite. The secant is the hypotenuse over the adjacent. And the cosecant is the hypotenuse over the opposite. Okay, let's do an example.
There's an opposite one too for the other ones. That's the reciprocal. What is it? SOHCAHTOA.
Oh, I don't know that one. Never heard that one. That's funny. She's got all kinds of good things going on over there. Okay. She has so many crazy ways to remember things. So cool. Okay, so let's do an example together. I'll give you 2 sides of a triangle. I'll say that this side is 1 and this side is 3. That's all I'm going to give you. And we want to figure out the ratio of all the sides in terms of the trig functions. This is the same box, okay? So we know that I don't have this side, do I? That's a question mark. Can I get it? Is there some way I can get it? How do I get it?
Do the Pythag.
We do the Pythagorean theorem. So I'll say a squared plus b squared equals c squared. So a squared I'll just call 1 plus b squared equals c squared, which would be 9 in this case, right?
Yes.
So b squared has to be 9 minus 1, which is 8. So that means that b must be 2 rad 2. Okay? Now that I know what this is 2 rad 2. I can write that down. And I can figure out all the ratios of all the sides. So the sine of my angle theta has to be the ratio of the opposite over hypotenuse. That has to be a 1/3. So that means that the cosecant of theta must be a 3. The cosine of my theta must be 2 rad 2 divided by 3, or the adjacent over the hypotenuse, which means that the secant of theta has to be 3 over 2 rad 2. But can we leave it like that? No. So multiply top and bottom by rad 2 over rad 2, which then gives us 3 rad 2 all over 4. Because rad 2 times rad 2 is just 2, times 2 is 4. Okay, moving right along. The tangent of my angle theta has to be the ratio of opposite to adjacent. So that's 1 over 2 rad 2. And then I have cotangent of theta is just 2 rad 2. I did that one first because all I have to do is take the reciprocal. Tangent, I'm not allowed to leave like that. I need to multiply out rad 2 over rad 2, which gives me rad 2 over 4. So there you go. And now I have all 4 of my trig angles given to me in terms of theta. Cofunctions. Do your best to draw a right triangle. Give yourself an angle measure of theta down here, which we'll call 32 degrees. And this is 90 up here. All right, so what I would like you to do is I'd like you to experiment. Can you please tell me what is the sine of 32 degrees on the calculator? So right now, go ahead and figure out the sine of 32 degrees. Make sure your calculator is in radian mode. Okay? I mean, sorry, degree mode. Yeah, thanks. I meant degree mode. Yeah, you got it.
Wait, what is that?
Whoa. There we go. Okay, I got all kinds of things going on here. So to make sure you're in the right mode, go to on, go to mode, and make sure that you are in degree. Go down, go over to degree, highlight that, hit it. And then let's figure out the sine of 32 degrees. So sine 32. I'm getting 0.52999. Getting that same thing? So how about like 0.53? Sound good to you?
Yeah.
Okay. So let's call this 0.53 roughly. Okay. All right. Now, since I'm dealing with a triangle, a right triangle here, what is the measure of this angle right here?
I mean, no. Wait, no.
What?
58.
58. How'd you get 58?
90 plus 32.
90 minus the other angle, right? 32? Is that right?
Yeah, minus.
Yeah, because this angle is 90. This is 32, so this has to be 90 minus 32, which is 58, right? So that means that this angle here and this angle here together add up to 90 degrees. Is that true? And yikes. Oh my gosh. Okay, thank you for that. I'm so oh my god.
Just swipe from the left.
Swipe from the left. Thank you so much. You're the man. Okay, so Windows 8. Awesome. So they add to 90. What's the name of two angles that add to 90 degrees? There's a name for that.
Oh, yes.
Complementary, right? Okay. So here's what I'd like you to do. With your calculator, what is the cosine of 58 degrees? Go ahead and plug that in your calculator. Tell me what you get. Cosine 58 degrees. Notice that you get exactly decimal for decimal the exact same thing. The reason is because sine and cosine are what's known as cofunctions. Notice you get the same thing. Those are the same. Does anyone realize what the co in front of sine means? It means complement to sine. That's what it means. Okay, so here's what we can say. If we have two angles that are complementary and we have complementary functions, then they have to be equal to each other. So we're discovering here that the sine of theta is the same thing as the cosine of 90 minus theta. And the same is true for the cosine of theta. It's the same thing as the sine of 90 minus theta. This right here, these are a pair of co-functions because sine and cosine are co-functions together, complement sine.
Can you repeat what you said earlier? There are two angles that are complementary
and our sines are co-functions of each other, then they're guaranteed to be equal. So there are two other pairs of co-functions. What are the two other pairs of co-functions? Kimia just gave me one. What are they? Yeah, so the secant of theta must be the cofunction with cosecant of 90 minus theta. These two will be guaranteed to be equal. And likewise, the cosecant of theta is the secant of 90 minus theta. That's another pair of cofunctions. There's another one. What is it? Yeah, tangent and cotangent. So the tangent of theta is equal to the cotangent of 90 minus theta. And likewise, the cotangent of theta is equal to the tangent of 90 minus theta. So each one of those are co-functions of each other. Cool. Let's do these together. The sine of 63 degrees has to be equal to the cosine of what angle?
27.
27 degrees. How'd you do that? You're totally right. What'd you do?
90 minus 63.
90 minus 63 is 27. Good. How about this one? The cosine of 42 degrees has to be the same thing as the what of 48 degrees? The cosine. Very good, right? Oh, wait, yep.
Sine.
Sine. Ha. Got me on that one. Sine, right? Because 42 and 48, those are complementary angles, and sine and cosine are cofunctions. So therefore, those two angles have to be the same. What about this one? Little curveball for you. If what the tangent of pi over 4 is the same as the cotangent of what? Also pi over 4. How come?
Oh,
2 pi over
90.
4.
Yeah, because pi over 4 and pi over 4 each are 45 degrees. They add up to 90, so they're complementary. Tangent and cotangent are cofunctions of each other. What about this one? The what of pi over 3 is equal to the secant of pi over 6. Cosecant, very good. Because pi over 3 and pi over 6 are complementary, and secant and cosecant are cofunctions. Last one, this is the most challenging one. If I tell you the cosecant of pi over 12 has to be the secant of what? 5 pi over 12. Very good, Jonathan. How'd you do that?
Pi over 12 plus 5 pi over 12 is the same as pi over 2.
Yeah, so pi over 12, or sorry, pi over 2 minus pi over 12 gives you 5 pi over 12. So this is our 90 degrees minus our theta. Okay? What do you think about that? Pretty good? Okay.
Thing down there.
So this is you standing on a cliff. Down below you is a rock. Above you is a tree. So I have to introduce some terms to you before we can start talking about applications, right? From your eyesight straight out, straight above right here, okay, that's called the horizon or the horizontal. So from your eyesight straight out is called the horizon or the horizontal. If from your eyesight you look straight down at this rock here, then with the horizon here, there's a little angle that's created. So do you see this angle? It's in between the horizon and what your line of sight down to the rock. That right there is called the angle of depression.
Oh, I remember doing this in geometry.
Yes. Okay, that's your angle of depression. I want you to make sure you know how to draw it. So we're talking about angle of depression is in between the horizon and your line of sight looking down. Now if you're looking up from your line of sight to the, say, like the top of the tree over here, then your angle looking up, this angle here from the horizon up, is called the angle of elevation. So we have these key terms here that we need to be responsible for. Straight out is horizontal, up is angle of elevation, down is an angle of depression, and each of these right here, this one and that one, are called lines of sight. So a line of sight.
Oh, wait. I missed the line of sight.
The line of sight is just from your eye to the rock or from your eye to the horizon or to the top of the tree. Those are your lines of sight.
Wait, is the elevation the angle?
Okay, do your best to draw yourself. Looking at a building over here. Okay, my building is flat right now. It's a very short building, yes, you got it, yeah. Not drawn to scale. So, from your eyes, straight out, here is the horizon. Okay, you have a line of sight, angle of elevation of 21 degrees. So the way that you draw the angle of elevation is from your line of sight up. So this angle here represents 21 degrees. So that's my angle of elevation. I have a 21 degree angle of elevation. Turns out this person from the ground up to the eyes is 6 feet tall. Okay? So from the ground to their eye level is about 6 feet tall. You got to know that part. And I have I'm created a right triangle here. We can assume that the building is built perpendicular to the ground, hopefully. Otherwise, it'd be kind of leaning, and then that wouldn't be very good for office work. So I have this triangle here, right? I have a right triangle here, which I'm kind of highlighting right now. There's a right triangle there. So I'm going to call this side A, and I want to find the height of the building. I still need something, right? What would be a good thing to know in this particular case? I need something, right? Yeah, exactly. How far away from the building I am? I am 250 feet away. Obviously, this is not drawn to scale. We're just going for conceptual knowledge here. Okay, so if I'm 250 feet away, that means that my distance from my horizon line is 250 feet.
So is the horizon 250 feet?
What's that?
Is the horizon 250 feet?
Yep, you got it. So that means that this is 250 feet. It's the same thing, right? So can I get A? Using some trig? I sure can, right? I could say that the tangent of 21 degrees has to be the value of A divided by 250. Now, why did I choose to use tangent? Because I have an opposite and an adjacent. That's what I'm looking for, right? So that means that A must be equal to 250 times the tangent of 21 degrees. Well, the tangent of 21 degrees is just a number which we can calculate. So if I take my calculator out and I plug in tangent of 21 degrees, sorry, it's just some decimal. There it is. I take that and I multiply it by 250 because that's how far away I am, times 250. So I'm coming up with 95.97 when I round to two decimal places, right? So A is a value of 95.97 feet. Is that what I want?
No.
No, I still have to do one more step. What is it?
Add the 6 feet.
I gotta add in how tall my angle of elevation is, or sorry, how tall I am standing above the building, right? So I gotta add on that 6 feet initially to give me a grand total of 101.97 feet. So check it out. I have the sun, and let's say I have a flagpole over here. Okay? And here's my flagpole. Ooh, that's a good flagpole. That did good. Okay? And there, the sun is beaming down, hits the flagpole, and then creates a shadow on the ground. Right? So there's a shadow on the ground over here. Check out my cool little shadow that I have on the ground. So here's what I know. I know two things about this picture. I know that the flagpole is 33 feet tall. And I know the shadow it casts is 47 feet long. The question is, what is the angle of elevation to the sun then? How high is the sun in the sky? Well, we can calculate that using trig. We can say, all right, the tangent of my angle must be the ratio of 33 to 47, which is the opposite over the adjacent. But I'm not interested in the tangent of my angle. I actually want the angle itself. So the angle itself must be equal to the inverse tangent of 33 over 47. This part says the angle whose tangent is the ratio of 33 to 47. So the question is, how do we get it? Well, our calculator has a great button on it called the inverse tan button. I'm going to show it to you right now. So if you turn your calculators on, do you see where the tangent is? You see above tangent there's a little yellow, it says tan with a -1. That does not mean the reciprocal of tangent. It means the inverse of, it means the tan inverse. So we're going to go second tangent, and then we're going to go 33 divided by 47, and we get an angle of 35.07 degrees. So we can actually figure out angles of elevation to the sun based off shadows. So I'm getting 35.07. So the angle is approximately 35.07 degrees rounded to two decimal places.